Welcome to Zaption Tour 87, factoring special cases. There are 5 boxes. Let's get right into it here. The first box is understanding how to factor what we call a perfect square trinomial. Now, this is a phrase or words that we want to get really familiar with. So what is a perfect square trinomial? Well, in class we've been studying these two particular squares of binomials. So you'll recall, this should be review right here, you'll recall that a plus b squared is equal to a squared plus 2ab plus b squared. So whenever you have something whenever you have this form, something takes that form, this is called a perfect square trinomial. Same thing with down here, a minus b squared. Well, you'll recall, like I should have done this in the first one, but what we have is this means a minus b times a minus b, right? And this always ends up being a squared minus 2ab plus b squared. And again, this thing is now called a perfect square trinomial. The reason we call it a perfect square trinomial is because it ends up being a trinomial, so that's where the word trinomial comes from. And perfect square comes up from something being multiplied by itself, perfect square. So you end up with a perfect square trinomial. We want to get really good at recognizing perfect square trinomials because they always factor back to the square of a single binomial. A lot of words going on here, so I hope it's making sense so far. Let me give you 2 examples here. This right here is a perfect square trinomial. The reason it is because it can factor to x plus 4 quantity squared. Well, how did I do that so quick? How did I see it? Well, here's what I looked at. I saw that the first term was a square, the last term was a square, and the middle term is 2 times the first term and the last term. So it's something that you look for and see. So let me do another one for you, okay? This is also a perfect square trinomial. This is the number or the variable 2x all squared, right? If I take 2x and I square it, I'll get that. This is a square too, all right? It's a positive 3. So I know it's going to be 3. So I know this is going to be the answer, and this is how I know. So that's 2x all squared. This is 3 all squared. This is minus 2 times the first term, which is 2x, times the last term, 3. So look, it has the form. It has the form of this right here. This is my a squared minus 2 times my value of a times my b value plus a b squared. So I recognize that it is a perfect square trinomial, and it will always factor to, look back to what it was originally, a minus b quantity squared. So this is what we're doing. We're just recognizing special cases, and the first special case is called a perfect square trinomial. Okay, box number 2 is another example. It says factor, and I'm noticing that this is another perfect square trinomial. The reason I know is because the first term is squared, the last term is squared. So this can be represented as x quantity squared. This can be represented as 6 quantity squared. And then I could write minus 2 times x times 6. 2 times x times 6 gives me 12x. So therefore, this whole thing is going to factor to x minus 6 squared. And if you don't believe me, or if you don't see it, if I took x minus 6 and I multiplied it by x minus 6, I would get this. I get x squared minus a 6x minus a 6x plus 36. And there you have it. X squared minus 12x plus 36. So yes, it definitely does indeed. It is indeed a perfect square trinomial. Box number 3 is another example. And I'm noticing that this is another perfect square trinomial. The reason I notice is because I look at the first term, and this is like x being squared. I look at the last term. This is like the number 3 being squared. And I can write the middle term as 2 times the first term times the last term. 2 times x times 3 is all worth 6x. So therefore, this will factor to x plus 3 quantity squared. Box number 4 is a you try. Go ahead and recognize that this is a perfect square trinomial. See if you can factor it. Hopefully you got the right answer, but here you go. Noticing that this is a perfect square, so this is going to be an x quantity squared. Noticing that this is the number 7 quantity squared. And I could write this number as a negative 2 times x times 7 Yep, that gives me the negative 14x. So therefore, the answer should be x minus 7 quantity squared. And box number 5 is under the last special case that we're going to talk about today is the difference of two squares. So I want to talk about the words. So the word difference comes from right here. Okay, it's a minus sign. It's the difference of two things being squared, two numbers, two variables, two terms being squared. That's called the difference of two squared. The difference of two squares. So it will always, always, always factor to a plus b times a minus b. It'll always factor to this, okay? I want to point something out to you that you can see in the bottom left of your screen here. Note, a squared minus b squared is not the same thing as a minus b all squared. Very, very important that we understand that rule. That's not the same thing. Let me give you two examples over here. So I have x squared minus 16. I'm noticing that this is the difference of two squares because I could write it as x squared minus 4 squared. That will always become x minus 4 times an x plus 4. Okay? Down here alone, the difference of two squares, x squared minus 64. Well, that's the same thing as x squared minus 8 squared, and now I have the difference of two squares. So it will become x plus 8 times x minus 8. It doesn't matter if you do the positive one first or the negative one, as long as they're both represented because multiplication is commutative. Okay, there is one more thing I have to warn you about here in this case. A lot of students don't see this as the difference of two squares. And this is because the very first term, 16x squared, can be written as 4x all squared. So take a moment and realize that that is indeed true, because 4x all squared gives me 16x squared, minus 81, of course, is 9 squared. So now again I have the difference of two squares, so it can be factored as 4x plus 9 times 4x minus 9. And there are two special cases that we were talking about today: perfect square trinomials and the difference of two squares.